The next metric that we will learn is meteor. The name is very beautiful. It's very pretty. Meteor means the metric for evaluation of translation with explicit ordering. So they make this one as one word, meteor. It incorporates recall, precision, and additional semantic matching based on stems and paraphrasing. Stems is for the stemming, and paraphrasing. So you have one word that you have one sentence that can be paraphrased. It is in the different sequence, but the meaning is the same. So let's say I have a reference. The cat is sitting on the bed. And the generated text is a cat sits on the bed. So it is this common practice. And if you look at the unigram, you can have like this one. So the and is not the same. Cat is the same. Is and sits, they are not same. Sitting, yeah, we cannot have any sits. On, it's the same. The is not the same. Mat is the same. So we can see that there are 1, 2, 3. They are overlap. Then the precision means the number of intersections, there are 3, and we want to divide with the total unigrams in the generated summary. So the generated summary means this: a cat sits on the mat. So 3 divided by 5. And we can measure the recall. So the recall means the number of intersection, which is 3, divided by the number of unigram in the reference summary. So the reference summary, we have 1, 2, 3, 4, 5, 6, 7. So 3 divided by 7. So we can calculate the F1 score. The F1 score is 2 multiplied by precision multiplied by recall divided by precision plus recall, and we get this value. And for this method, we will have a penalty P as the fragment. So to compute the fragmentation penalty, or we call it P later, we need to count contiguous or continuous matching segment. Continuous. So if a word is continuous, then we will make it as one segment. If it is not continuous, then we just make it as a separate. For example, in this example, segment 1 is cat. It is a single word. So segment 2 is unmet. So this is the first segment, this is cat. And then the second segment is unmet. Unmet. We can say this is a segment because it is continuous. So the segment selection can be varied. The segment selection can be, there will be several alternatives. For example, if you look at this data in the generated text, outlet is a segment. Cat. So this is one segment, this is another segment. Sometimes we will apply with TOS tag. You still remember TOS? We select the word, for example, cat. It is noun. Unmet. So this is a kind of preposition. This is noun. So if there is a preposition with a noun, then we can make this is one segment, and so on. So there are several alternatives to create segment. So let's say, we know that the segment is cat for segment 1 and segment 2 is unmet. So it is a single word, and this segment has two contiguous words. So we have two segments. For the segment, the fragmentation penalty P, so we have the formula 0.5. So this is just a number to represent the weight or the capacity. It will be multiplied with the number of segments divided by the number of matches. So we have two segments, cat and unmet. So this is one segment, this is one segment. Among the two segments, among the three matches, we have two segments. Then 0.5 multiplied by 2 divided by 3, then this is the penalty, 0.33. So the material score can be defined as the F score, which is the F1 score, multiplied by 1 minus P. P is the penalty from this segment. So we have the F score is 0.5 and the 1 minus P is 1 minus 0.33. Then the result is about 0.33. So the difference in length is naturally reflected in the precision and recall calculation. So this is how to calculate the meteor. I have the Google Colab. Maybe let's discuss the Google Colab on next Tuesday, okay, because Tuesday we have 1 hour. I will discuss this Google Colab for the metrics and the Google Colab for the algorithm at the same time. Now let's discuss the algorithm. What are the proper algorithms for the text summarization? As you know, there are two types of text summarization. The first is extractive text summarization, and the other is abstractive text summarization. For the extractive means we are going to extract text based on some factors, such as the text to be summarized, or we will see the most essential sentences, or we call it top, okay? And the importance of each of these phrases to the overall subject. So there are several factors to extract the text. So let's see with example. Let's say this is a very long document and we can make into 3 sentences. So the sentence 1, artificial intelligence is transforming industries. Sentence 2, AI is an important field of research. And sentence 3, AI has application in healthcare, finance, and many other areas. So we can use the TF-IDF summarization. Okay, what is TF-IDF summarization? We will apply the TF-IDF. And we're going to select the sentences which have the higher score. So let's say with the stop words removal, we want to remove stop words. So the S1, the sentence one, will be artificial intelligence transforming industries. S2 will be AI important field reasons. And S3 will be AI application, healthcare, finance, and RX. Okay, so let's assume that this is the features. So when you do your final exam later, you can make this assumption. I want to remove the stop words. That's okay. And then please define what are the stop words in this case. So maybe you will make is the stop word, un stop word, off is the stop word, in the stop words, and is the stop words, many is the word many, other is the word other. So I want to just focus on the important word. Maybe this is also has. So I put also has. Has is also the stop word. So if you put the list of the stop word like this one, then I can understand the result will be like this. So you already know how to calculate the TF IDF. So this is the TF from the document 1. This is the TF. And then this is the TF IDF 1, TF IDF 2, and TF IDF 3. So the TF1 is 0.25 for every of the text. The TF2 we have this one, and the TF3 we have this one. And using this TF IDF is simple. We want to do the summation from the TF IDF result. From the TF IDF result, so the document 1 or the sentence 1 is 0.4772. The document 2 is 0.4019. And the document 3 is 0.1468. Based on this result, the highest scoring sentence is sentence 1. This is the highest scoring. Then we can just make a summary. The summary will be artificial intelligence is transforming industries. So this is the sentence 1. So we know this is the extractive summarization. The other algorithm is text rank algorithm. The text rank algorithm, it is based on the page rank algorithm. Page, it means it refers to the web page. Web page, yeah, you know, in the web, in the internet, we have like Google, Naver, and so on. So we want to know the page rank, or we usually call the ranking of web pages in online search result. So whenever you do the searching, you will see some result. So the result will be ranked. This is rank number 1, this is rank number 2, this is rank number 3, this is rank number 4, and so on. How they can get this rank? So there are some numbers, how to calculate the similarity between your query and the result. So the page rank, in this case, it is to know the closeness between one web and another web. So for example, we can have this formula. So PR means the page rank of a particular page, and we have D. D is damping factor. So the damping factor means the decreasing value. Typically, it is 0.85. So sometimes they already define this damping factor as 0.85. And it is the total number of pages. So I give the example of 4. So later we will see this one is 4. In. So this is the set of pages linking to. So we check this one in. And then Li is the number of outgoing links from page I. Li is the number of outgoing links from page I. So PLI is the page rank of the related web. So let's see. Suppose we have 4 web pages. We have W1, W2, W3, and W4. So these pages contain links pointing to one another. Some pages might have no link. No link means we call it dangling pages. Dangling means no link of the related pages. So let's look at this matrix. We have web 1, web 2, web 3, and web 4. So the web 1 has link to web 4 and web 2. So we can make a kind of graph. So the W1 is a node. W1 is a node, and it is related with the W2, with W4. So web 2 is a node, and it is linked to W3 and W1. W2 is linked to W3 and W1. W3 has no link, so it is not related to any other. W4, it has one link, W4 to W1. So this is the graph from this matrix. And we can measure the number of outgoing. The number of outgoing means from W1 we have 2 links. So the W1 is connected to W2 and W4. So there are the W2 it is connected to W3 and W1. W3 and W1. So there are 2 outgoing. W3, there are no other web that are connected to W3. So we call this is pending page. And W4, it is connected to W1. So we have 1 outgoing. So the definition we can have like this one. Web page W1 has link directing to W2 and W4. Web W2 has link for W3 and W1. W4 has link only for the web page W1. And W3 has no link, and hence it will be called as a dangling page. So in the page rank, dangling nodes. So this is we call node. We call node. Nodes with no outgoing link. So there is no outgoing, from W3 are typically handled by redistributing their page rank equally to all nodes in the network, as if they link to every page. So if there is no link outgoing from this one, so we can say that we assume W3 is connected to W2, W1, and W3 and itself. So it is redistributing their page rank equally to all nodes. So this is done to prevent them for trapping page rank. So we do not want to put 0 to avoid this trapping page rank. So let's see with example. So let's assume the damping factor D is 0.85. So we have the page rank. The initial value of the page rank we need to set up with the 1.1 divided by 4. Why it is 1 divided by 4? Because we have 4 pages. So 1 among 4. So the W1, PRW1 will be 0.35. W2, then it will be also 1 divided by 4. W3 is also, we have the page rank is 1 divided by 4. W4 we also have 1 divided by 4. So all of them initial. The initial value is 0.35, 0.35, 0.35, 0.35. So if you have 5 pages, then each page will be 0.2, 0.2, 0.2, and so on. If you have 10 pages, then each page will be 0.1, 0.1, 0.1, and so on. Because we have 4 pages, so the page rank initially will have 0.1. Now, we will calculate the page rank W1 with the formula. What is the formula? We want to check the new page rank with the damping factor. So the damping factor means the deterioration, or we got the deteriorate, if it is connected with the other page. So this 0.85, we have 1 minus 0.85 divided by 4. So 4 is the number of pages that we have. So this is from the formula. 1 divided by 1 minus d divided by n. N is the number of pages plus b multiplied by the sigma. So what is the sigma here? Sigma here is the summation of the web where it has the link to other webs. So for W1, it has link to W4 and W2. And we have the W2 PR means the page rank W2 and PR W4. Yeah, this is the page rank of W4. We will divide with the Li. Li means the outgoing node. What is the outgoing node of page 2? The outgoing node of page 2, there are 2. Then we divide with 2. The outgoing node of web 4, there is 1. So we divide with 2. So after we have this value, then we can just do the summation. The value is 0.35 to 0.35625. This is the new pitch rank of W1 after we look into the web 2 and the web. What about the pitch rank of W2? The same, we can calculate. For the web 2, we have 1 minus d divided by 4 plus d multiplied by the summation. The summation now you can see here in W2 we connect with the W3 and W1. So W1, W3. And if you look at this W1, we have 2. 1, 2. So we divide with 2. For W3, we have how many of them? 0. So if this one is divided by 0, what happens? Everything multiplied by 0, it will be infinite. Then we want to avoid this 0. That's why we call this is the dangling pitch. So we call dangling pitch. What does it mean by the dangling pitch? This is the pitch without outgoing nodes. As I mentioned before, this is the dangling pitch. Dangling pitch is the pitch with no link. So pitch with no link. Then we will redistribute it equally to all nodes. Equally to all nodes means because we have 4 nodes, then we will divide with the total number of nodes. So we divide with 4. Why? We need to divide with this value. So it is to make sure that we have a value, but the value will be very small. So if the number of nodes high, then the value will be very small. So if the number is high, then this will be small. So at least we have a number. This idea is similar with the Laplace, if you still remember. In the Laplace smoothing, we want to avoid 0. In order to avoid 0, we will do the plus 1. And we will divide with the number of vocabulary. So the number of vocabulary will be very high. So if the number is high, then at least we have a value without 0. So it is the same. We want to avoid 0. Then you can get this value 0.225. What about the PR pitch rank of W3? For the PR pitch rank W3, as you know, it is dangling pitch because we don't have any outgoing link. Then you can just use the 1 minus d divided by 4 plus d multiplied by all of them. So PRW1 plus PRW2 plus PRW3 plus PRW4 divided by 4. And then we can get this one 0.7. And the last one is PR, the pitch rank of W4. The PRW4, it has one outgoing link, which is W1. So we just multiply with the pitch rank W1. Then we can get this value. So this is the new updated value after we do the first iteration. So we call this is the iteration 1. So the iteration 1, we will get this result. After we have the iteration 1, we will do the next iteration. So the first iteration, we will have the value PR, pitch rank W1 is this one. PRW2 is this one, PRW3 is this one, and PRW4 is this one. Then we want to make sure that it will converge, or we call it the convergence in the pitch rank. The convergence means we calculate the pitch rank until it converges, or it changes in very little number. For example, if the changes is 0.001, so this is iteration 1, and then there will be iteration 2. I don't show the iteration 2 here, but you can check. If the iteration 2, let's say 0.3612, maybe, I don't know. Okay. Then still there is a changes 0.01. So if the changes is very small, or if it converts, so it means there is no more changes. So converts means no changes anymore. Then yeah, we call this is converts. Or if the changes is very little, then we stop. After we stop, we will check the importance. So usually, yeah, in some of the research paper, they mention the repetition will be 20 until 30 repetition. But yeah, it depends on the data. So finally, the ranks have stabilized to represent the importance of each bit in the network. So let's say this one is the final result. Okay, after several iteration, okay, we can get this. So what does it mean? The highest number means the most important bits. So the most important bits is W1, follows with W2, W3, and W4. Okay, this is the number to represent the importance. So this is the pitch rank algorithm. Now, how if we apply this to the text rank algorithm? Using the idea of the pitch rank, we are adopting the pitch rank. So we have the S1, S2, S3. So let's say I have this one. Artificial intelligence is a branch of computer science. Machine learning is a subset of artificial intelligence. AI is used in various applications, including robotics. So we have we will tokenize. So S1 we will tokenize. So suppose each sentence is a node in a graph. So this is one node, this is another node, this is another node. So I have S1 is a node, I have S2 is another node, and I have S3 is another node. After stop words removal, so we can remove the not important words like is, of, you can assume that one, including use. Here, use is also removed. Then it becomes like this one. So let's use these features. So using these features, the S1 contain 1, 2, 3, 4, 5. So there are 5 words. The S2 contain 1, 2, 3, 4, 5. It contains 5 words. And S3 contain 1, 2, 3, 4, 5. AI various applications including robotics. So why I put 6? Hmm. Six. I think I put 6 with use. Okay, then maybe I will. Sorry, there are some typo in. Let me just use the use because this calculation is based on this number 6. Okay, okay let me just use the word use here. Sorry, let me just remove this one. So if it includes use, so the number where we have 1, 2, 3, 4, 5, 6. Okay. So I want to make 6 to distinguish with different words. So I want to know the connection or the similarity between the sentence. You know what is the similarity? We want to see the similarity between S1 and S2. We want to know the similarity between S1 and S2. So in the S1, we have 5, 1, 2, 3, 4, 5. In the S2, we have also 5, 1, 2, 3, 4, 5. And then we have unique words. Unique words means we remove the intersection. The intersection here, we have artificial intelligence. Artificial intelligence. So we have 5 from S1 plus 5 from S2 and minus 2, which is the intersection. Because we have 2 common words. Then there will be 8 unique words. Among the 8 unique words, we have 2 words that are common words. So we can say 2 among 8 unique words are similar. So we have the similarity is maybe the weight is 0.25. Then if we make the graph, it will be something like this. S1 and S2, we have the weight. The weight is 0.25. What about S1 and S3? S1 and S3, no common words. Why there are no common words? Because this one artificial intelligence, it is in short AI. So there is no common words. This application including robotics. Then we have the unique words is 5 plus 6, then it is 11. And the score is Q. Okay. No common words between S1 and S3. So we can just put Q. And the S2 and S3, S2 and S3, okay, I make mistake again. Oh, why I make another mistakes? Okay, I will fix this one. This is, I calculate this one based on the artificial and intelligence. So we have the 0.22. I will fix this one and I will let you know on Tuesday. Sorry for this one. So how to use this rank? So let's suppose we have the initial value. Okay. The initial value means if we use the pitch rank, because we have 4 at the time, W1, W2, W3, and W4. So each of the pitch will be 1 divided by 4, 1 divided by 4, 1 divided by 4, and 1 divided by 4. It is for the initial value. So you can define the initial value for the text rank. Let's say in the sentence 1, we want to make the score is 1. For the sentence 2, we want to make the score is 1. And for the sentence 3, we want to make the sentence score is 1. And then apply the iteration. So you know the pitch rank iteration. It is the 1 minus d divided by n plus the d multiplied by the sigma of the pitch rank divided by the outgoing, or this is the weight between the W1 with another value. So in this case, we have S1. So we want to know what is the weight between S1 and the other sentence. So we have we have this one. The S1 and S2, we have the weight 0.25. The weight between S1 and S3 is 0. The weight between S2 and S3 is 0.22. So I will fix this one. This is still not correct. So using that one, we will do the iteration, the same as the pitch rank. And let's assume after few iterations, we have this rank. So maybe after 10 iteration or maybe after 20 iteration, we have the S1 is 1.15, S2 is 1.10, S3 is 1.05. So we will select the top scoring sentence. The top scoring sentence means the highest score. Then in order to summarize, we can use the sentences with the highest score. So the highest score is 1.15, which is S1. Then for the text summarization, we can use the S1, the artificial intelligence brains computer science. And if this does not match, we can use the alternative, the rank number 2, which is F2, which is machine learning subject artificial intelligence. So this is the result for the text summarization after looking at the numbers after 3 iterations. The other algorithm, we want to look at the abstractive text summarization. So in the abstractive text summarization, it creates readable sentence from the complete text input. So large volumes of text are rewritten by producing acceptable representation. So acceptable representation, we want to look at the proper words that are good based on the analysis and the summarization with NLP. Now, there are many good techniques, good approach like BERT, BART, and so on. So we will learn those things next week. So the simple approach is using the frequency-based abstractive summarization. So we just calculate the frequency. And based on the frequency, we will extract the weight. Extractive the weight means it borrows from extractive methods by calculating sentence importance based on the word frequency. And we can do the abstractive derive. It uses key sentences to create a concise and paraphrase summary, and hence introducing an abstractive element. So this idea is the foundation of the Lex rank. There is another algorithm, we call it Lex rank, and also the text rank. So the text rank is for the extractive selection. And yeah, we will check this one also later. The set to set, it means sequence to sequence, or we can use also the transformer models. It is for true abstract summarization that generates new sentences. So let's say we have a sentence like this. Artificial intelligence, AI, is revolutionizing various industries. It enhances efficiency and automates tasks. Companies are using AI for data analysis, customer service, and product recommendation. However, ethical concerns about AI's impact on jobs and privacy must be addressed. Now, how can we make the text summarization with this one? So first, we need to identify the key sentences. The sentence one, this one, AI is revolutionizing the various industries. Sentence 2, it enhances efficiency and automates tasks. Sentence 3, we have companies are using AI for data analysis, customer service, and product recommendation. And sentence 4, it is ethical concern about AI impacts on job and privacy must be addressed. So we know this is the sentence tokenization. Okay, you already know about this one in the early chapters. After we make the sentences, yeah, this is just a very simple idea with the frequency. So you can measure the frequency for every of this sentence. So the word AI, there are 4. So let's say the artificial intelligence, we also calculate as AI. And then the other words, we have 1 for each. So it is totally different words. Revolutionizing various industries, enhance efficiency, automates tasks, companies. So every of them will have frequency equal to 1. So after you remove the stop words, let's say the stop word is, the, on, and B, and so on. So we have the total words. So the total words, let's say this one is 26, excluding the stop words. And yeah, using the very simple calculation, we can get the score. What is the score? The score is based on the frequency. So AI is revolutioning various industries. So the word AI, because there are several AI, so we see from the frequency, the AI appears 4 times. Then 4 for the important words. Revolutionizing is 1 industry is 1 time. So the total is 6. So the other is 1, 1, 1, 1. So we have 4. This is companies, AI, data analysis, and so on. So we have the total is 11 based on the frequency. This one, we have the total score is 9. So we can select the highest score. So the highest score is 11. So we can say that, okay, maybe we want to select the top 2, this one and this one. So we select this one and this one. After we have these 2 sentences, so we can paraphrase. You know what is paraphrase? We change the word, but the meaning is still the same. We have these 2 sentences and we paraphrase the key sentences. So the abstract summary will be a new text like this one. Maybe, yeah, this is an example. AI is widely used in data analysis, customer service, product recommendation, but its impact jobs and privacy raise important ethical concerns. So this is one example of the abstract text summarization. Okay, I will explain the Google Colab on Tuesday. Okay. Any comments, questions? Rồi,